Okay, so let's briefly digress towards other views of learning, and then I'll show you a puzzle, and then we will discuss that puzzle later. So other views of learning. So remember, learning is a very broad premise, and it's cropped up and even created other disciplines. Okay, so let's first distinguish learning from design. Okay, so learning is occurring from data. Design occurs from specs and a model. So let's say I wanted to design, a vending machine that, recognizes dimes and quarters. So what do? I call up the US Mint. I get, the specifications by which, the quarters are made and the dimes are made, and then I can build a formula that says, if the radius is above this value, then it's a quarter. Okay, so that's if you give me perfect specs for a problem, I can design a solution. That's kind of like the situation where I know the pattern. Okay, so learning comes in when you don't know the pattern. Remember, that was one of the fundamental requirements for learning to be relevant to solving a problem. Okay, now there are these fields like statistics, okay, which are mathematical. Statistics and function approximation, which are sort of very mathematical disciplines, where the goal is to derive rigorous answers to certain questions like, can I identify a probability distribution, or can I identify a linear regression, and what theorems can be proved. So in those settings, we typically make many strong assumptions and then prove a theorem like, if this, then we can identify the probability distribution. So it's a brand of learning because you use data to learn something, but it's sort of limited in scope because of the nature of the types of results you try to get, which are very rigorous results. Here we're going to take the opposite approach in some sense. We're going to assume that the type of function that you're trying to learn, we don't know anything about it. It is completely arbitrary. Okay? And then you get some data that represents that function, no matter what it is, and then we're going to give it a go with learning, and then we're going to see what happens and what can we conclude from what happens. There's a field called data mining that's focusing a lot on the sort of notion of finding patterns in massive data. It's very closely related to learning, and in fact, some learning courses masquerade as data mining courses, some data mining courses masquerade as learning courses, so those are very closely related. But from the perspective that we are going to present, data mining courses tend to be more algorithmic in flavor, more about, can we find all the patterns efficiently. Typically, data mining is unsupervised, but nowadays, data mining and machine learning are sort of sometimes used interchangeably. When it comes to learning, there are three main paradigms, okay? And the three main paradigms are supervised, which is the context of this course, okay? So where the data is, remember, xn and y, so you get an x and a y in the data, okay? So you are told the answer. So for my applicants in my data set with respect to credit approval, I am told that for this applicant, the correct answer should have been to approve. So I'm told f of x. Okay. Now, the other three paradigms are basically versions of the supervised paradigm where you change the data. Okay. So in the unsupervised paradigm, you don't give me f at all. Okay. So you just give me all the applicants. You say, here's a bunch of applicants. Okay. And the idea here is that you can learn to organize the data so that when later you give me a few values of f on a few data points, it might be very easy to then build a predictor. And a lot can be gained by an efficient and good way to organize the data. Okay. Reinforcement learning is a very common type of learning and it's a very intuitive type of learning because that's mostly the way we learn. Okay, so instead of giving you the right answer, I let you try something. So you're a child, you see a hot cup of coffee. I let you try to touch that hot cup of coffee. Okay, I let you try. You try and touch the hot cup, you get burned. Okay, you try, touch the hot cup of coffee, you get burned. Now, I'm not telling you don't touch the hot cup of coffee. I'm just presenting you with a situation. You try and get burned. You get burned. You get burned. Eventually, you'll learn that if there's a cup, that's placed on the table and it's got liquid in it and it looks this shape of a coffee cup, I'm not going to touch it. Okay, and you learn the correct decision, which is don't touch. Okay, but you didn't learn it because someone told you don't touch. You learned it because you tried and repeatedly got burned, and so you then inferred that, maybe it's better not to touch. But you'll never know for sure, okay? Because every time you don't touch, you are also probably feeling some pain. What's in that cup? What's in that cup? I want to touch. Okay, but so you never really know what's the right thing to have done, because you'll have many episodes of curiosity not being fulfilled. Okay, but you have to compromise between the amount of times you touched and got burned and the amount of times you didn't touch and your curiosity was not satisfied. Okay, so in reinforcement learning, you see an input, the cup of coffee or the cup containing liquid. You try something and you get feedback, and somehow miraculously you learn not to touch the cup of coffee. In fact, reinforcement learning is quite a powerful method of learning. It is this method that was used to create some time ago, create the world's best machine learning backgammon player. Okay. Let me show you a little bit about unsupervised learning, just to show you that organizing the data is a very powerful pre-processing step that can aid a lot in the learning process. Okay, so here is an example of a learning problem, just like the credit card approval, where instead of age and income, we look at size and mass of a coin. And if you plot the size and mass of a coin for dimes, pennies, nickels, and quarters, it'll look something like this, where the colors indicate, the denomination. And then if you are asked to separate these with a linear model, you might do something like what's on the right here. So anything below this first line is a dime, then between the first and second line is a penny, and so on and so forth. Okay, so you have learned from the data. Okay. Now, in the unsupervised setting, I'm going to give you this data, but I'm only going to give you the size and the mass. I'm not going to tell you that these are dimes and these are pennies. I'm not even going to tell you that there are 4 types of objects. I'm just going to give you a bunch of objects. Okay, and they're going to have different sizes and masses. So let's look at what that looks like. Wow, there you go. Okay, so that's the same data, but now I've removed the color because I've removed the label, the f of x. So x is size and mass, and f of x is the value of the coin. And I've removed the value, which was encoded in the colors. Well, when you look at this, you'll see that while, yes, there's significantly less information, when you look at this, at least as a human, intuitively you can identify some structure, okay, which you can try to organize into 4 types of objects. Okay, so here, when we have this unsupervised setting, we might still construct the same lines. Okay, so there's a lot of information here. I just don't know that what's below the first line is a dime. I just know that, it looks like there's one type of object here, another type of object here, a third type, and a fourth type. It's also possible that, you will say that there are only 3 types of objects, this big group here, and then this and that. And that's one of the challenges with organizing data, with organizing anything. So if someone comes to you and says, okay, my mom came to me when I was like 12 and said, Malik, you need to organize your books on your bookshelf. I'm looking at it and what the hell does that mean? Okay, but nevertheless, just organize them. Put at least the books of one topic on one side, and then the next topic, and so on and so forth. So I'm thinking to myself, okay, that makes sense. Let me organize my books. Okay, so I'm trying to organize. I'm trying to figure out how many topics. Okay, that corresponds to how many groups here would be appropriate for organizing this data on size and mass. And if you happen to decide to organize it to 4, then you might almost learn as much as in the supervised setting. Now if someone comes and says, you know what, this type 1 that you organized into, well, those are actually called dimes, I'm ready to go. Anything that comes in here I classify as type 1, and you told me it's a dime, so it's a dime. Okay, so that's unsupervised learning. And that constitutes the end of this lecture.